Hello. So we're going to begin with the overview of information systems, and we're looking at lecture 1. We basically begin with the simple definitions that will help us understand what information systems are all about. So we look at systems from the perspective that a system is composed of different components, and that's the reason why we use the term system to define it. So a system will have subsystems within it, that is components or other components that work together still within or under a specific unit to be able to achieve a specific objective. Now, since we're talking about information systems, then again there is the aspect of information that comes into play. And we know that when you're talking about information, we are looking at it from the perspective of where we have data that needs to be processed so that now it can lead us to information. Data is basically raw facts. Like example, if you're talking of an employee who works 5 hours and is paid at a rate of maybe 1,000 per hour, then we can be in a position to get the 5 hours and the 1,000 per hour, and out of that we are able to process and get information concerning the wage that this employee will be paid at the end of the day. So sorry about that. So now we come to the information system itself. Since we have already said that we have components within it that must work together to achieve a specific objective, then this implies that these components, since they are working together, then they are interrelated. And this is what we expect when it comes to processing of information and processing of this information within an organization, because we look at information systems as systems that work within an organization, and they work within an organization to achieve the objectives of that particular organization. You can see on the right side we have a diagram that shows us we have a figure that shows the input, the processing, and the output, and then there is a feedback loop. So for every system, since computer systems are mostly what we refer to as open systems, and open systems affect the environment, or they are affected by the environment, and that's why we have an input and then we have an output, because once we enter information into this particular system, then we expect this information. Now, this information we are entering is what in one level of organization can be termed to be data. In another level of information can be termed to be information. And therefore, I'm using data and information interchangeably when it comes to different levels within an organization. So once we enter data into the system, then it must go through the processing that we are talking about. It can be classified, it can be arranged, we can have further calculations happening to this kind of data that we are working on. Then eventually we get an output, and we can get output in form of what? We can get this output in form of reports that can inform us, that can allow us to be able to do further analysis and decide whether we still want to do some more processing and all that. Now remember, this input and this output is affecting the environment, and within our environment we basically we have suppliers, we have customers, we have regulatory agencies, we have stakeholders, we have competitors, and all that. All those form the basis of the environment that we are referring to. So there's a lot that happens. That's why we're talking of input, process, output, and the feedback. Now, the dimensions of information systems need to be looked at from the perspective of organization, the management, and the information technology. So those are three dimensions that we cannot remove from that aspect of information system. There must be the organization itself, and the organization itself, that's where we find the employees. That's where we find different cultures that are that are operational within those kind of organization. We find the politics of those organization. We find different ways that organization do end up achieving their tasks or performing the tasks every now and then. Now, they must perform those tasks using information technology. And the reason for use of information technology is to try to make things much more, to try to achieve whatever it is they want to achieve much more faster using technology. Technology does help us get things done much more faster. And therefore, now that's where now we have that aspect of information system. So we're looking at it from those three dimensions. There's a diagram that shows us organization, technology, and management. And under management, this is where we have the leadership of this particular maybe organization that we are looking at. How they are able to manage not only their employees, but also the data that or the information that they get from these particular systems. All in all, if you combine organizations, technology, and management, that's now when you begin to get the information system. So information system does not stand by itself. We need those different dimensions that we are talking about. And if we look at organization by itself, we're looking at people, structure, business processes, culture, and politics. All those will always be found in, regardless of whatever kind of organization that we are running. We are always going to find them there. Now, again, if you look at the upper level hierarchy, this is where we have the managerial or professional or technical employees, those who manage other employees. But we are saying that management does not only involve the employees. There are other assets within an organization that would also need to be managed. Because if you look at an organization, there's a diagram that we're going to see it later that tells us that we basically have the operational level, we have tactical or middle level, and then we have the strategic level, and that's where we find the senior management. And the senior management make decisions concerning the entire organization, and for them to make those decisions, they must make use of information systems. Now you can see the pyramid that we have here shows the operational management. This is where work that is of routine nature. And we have the middle management, where we have the scientists, knowledge workers, and all that. If you want to understand it clearly, just think of it as heads of department, because they make use of data or information that is collected from the operational level to make their own decisions. Then at the top we have the senior management, and senior management also use some kind of different information systems compared to the ones that are used under middle management and operational management. Their kind of systems that they use are more of systems that are graphical in nature, because they need to instantly understand information, make decision using that information. Now, the kind of systems they also make use of data that is coming from outside the organization and within the organization. So they must get the right information for them to be able to make the right decisions concerning how the organization will be run to ensure that it is a profit-making organizations. That's why they are the sense makers, they are decision makers, they are planners, innovators of new process, leaders. They're able to set agenda, they're able to set plans for these organizations. Now that will require what? Would require accurate information, and will require information that is instant. The moment they need that information, they must get that information, and needs to be current information. So we have technology dimensions of information system. Here we're looking at, if you're talking of information system under the the technology aspect of it. We are looking at hardware, softwares, data, networking, and all that. Because when you're talking of hardware, basically these are the tangible parts of a computer system. Software is the intangible parts of the computer system. These are the programs that we find installed within a computer system. Now we have the data management itself. It looks like the data that we are operating with, or that we are producing within this particular system, how we store it, how we are able to retrieve it, how we are able to share it, and all that. But for us to be able to share it, then we need to have an environment where computers are connected from one computer to another computer and so on. And that gives us now the computer network, because computer network is basically just a interconnection of computers within a particular environment. If you look at the basics of computing, you will hear that there's a local area network, there's a wide area network, there's the MAN networks and all that. But all that is based on what? Networking, different types of networks and all that. But regardless of that, we are basically just looking at how one computer is connected to another computer. And computers, or rather, if we have interconnection with computers that are far-flung areas, then now we bring in the aspect of telecommunication. Like when you're connecting your computer to another, you're trying to communicate with another computer that is maybe in another country and so on. This is where we bring in the telecommunication. You are connected via your telecommunication network, such as Safaricom, for you to be able to get internet and all that, and any other telecommunication company that can assist in all that. Now, business perspective on information system. First of all, you must understand that computer systems were created for the purpose of supporting business. That was the initial reason why computers were developed, because nowadays computers, we use them for different kind of purpose, entertainment and all that. So IS, which is information, are more than just technology. Business invest in IS in order to create value and also increase profitability. So if we are able to work much more faster, if we are able to work much more efficiently, utilizing lesser resources that we would have if we were not using computer systems, then there is value that has been created in use of such kind of technology. And therefore, IS would create the value primarily by changing business processes and management of decision making. With computer systems, you can make decisions much more faster. You can make accurate decisions, because computer systems, we can use them for purpose of ensuring that you have accurate and or rather correct information with you before you make a decision. So basically, the aspect of computer systems fall under the technology dimension of the IS. And that's how we are able now to create that value, as I've explained. So for a business perspective, IS are part of series of value adding activities. And that's basically why we use them, because we can run our organizations without the use of computer systems, but we would be able to achieve little, or we'll be able to achieve our goals at a much more slower pace. Now, we want to be in a position where we can be able to achieve our goals much more faster. We want to be able to have that assistive technology that can help us make the right decision. That's where the value is coming from. And remember, in a business environment, we have competitors who are also buying the better technology to help beat the competition. So you get value from that if you look at it from that particular perspective. Because if it comes to data collection and storage, then you need to make use of that data for you to be able to make the right decision. Then you must also clean that data, ensure you have the proper data. And that's why you can see we have transformation, into business systems. Then there is dissemination, ensure that data that you have collected gets to the right departments so that they can use that data for them to make better decisions. Now, these disseminations may be basically happening within the organization itself. Like we have seen, we have the pyramid that I just talked about, where we have under the lower part of that particular pyramid, we have the operational level. In the middle part, we have the tactical or middle management, and then at the top we have the strategic. Now, if you look at the figure that is shown here at the bottom, you can see we have support, business process, and operations. These are basically the operations that are of routine nature. Like, I'll give you an example of a supermarket. If you look at a supermarket, if you go to a supermarket, whatever you're going to be purchasing from that particular supermarket will be processed at the checkout counter. The operations that will be performed will be operations that are of routine nature. That is, the same operation will be performed when you have purchased maybe a toothpick. Is the same kind of operation that will be performed if you purchase a television, whatever it is that you're going to purchase all through the day. Same kind of routine over and over and over. So that is the operational level. From there, we can have now the middle management, or the tactical, where we have support business decision making. Here we can be making decisions concerning what particular kind of products and all that, and we would have heads of sections making decision regarding maybe a particular product. Is it moving, is it not moving, and all that. Then at the top of that, we have the strategic level, where they make decision concerning the entire organization. They don't, whatever they do is not based on a particular department. It's based on survival of the entire organization, and therefore it's all about strategy to ensure the whole organization is able to survive. Now you can see we have arrows that are pointing from one level to another. That is how the decision flow is moving, and that's how the information that is being processed is moving. You can see that we have support strategies for competitive advantage. That's the strategic level, and you can see arrows are moving to the middle management. They are also moving to the operational level. So they make decision concerning the entire organization. We talk of support of business processes, such as use of computer system, IS, and all that. That is where we add the operational level. Then we have support of decision making of employees, whatever goods they need to be added and all that. You can look at that based on which products are moving, which ones are not moving. Then the last one, the one that's at the top, they make decision based on what? Based on the entire organization, and therefore the kind of systems they require, as I had explained earlier, will be systems that will make processing of that information much more faster, and always ensuring that information and up-to-date information is always available to them. So now, if you look again, we have the contemporary approaches to information systems. Now we have the MIS there. Now, if you're talking of the management information system, then now we need to look at it from different approaches. We have the computer science. We have the operations research, and then we have management science. There's a whole kind of research that goes into ensuring that an information system is operational. We talked about the technology itself, and those are the technical approaches that will need to be implemented. So they are from management science, they are from computer science, and then they are from operations research. So all that falls under the technical approaches. Then we have the behavioral approaches. There's a way that information systems will influence how you work. Either it will make you work much more faster, and if you're not trained properly to use them, then you might not be able to achieve much it also affects your psychology. How do you work with this kind of system, especially when it comes to making decisions? So we have two other aspects or approaches that you may be that are available for us to be able to look at information systems. So we have the technical, and then we have the behavioral approach. So here are the two of them. We have computer science, established theories, computations, and then we have management science, development of models when it comes to decision making. Then the operation research will focus on mathematical techniques for optimizing selected parameters within an organization. And that's why you hear that within a particular organization we have R&D, that is research and development. They would look into all these kind of things. Ensure also that you have the right technology for you to be able to compete well against your competitors and all that. Ensure that your staff also, under behavioral approach, that your staff at the right position to be able to make the right decisions. This can also involve what staff welfare and all that. So all that we have sociology study, we would have psychology study, we would have economic study of IS with the interest of understanding the production of digital goods and dynamics. So we look at it from all those two different perspectives, and they are all related. Now, we can have, like, if you look at the figure that we have here, when we are doing our own kind of research from the technology perspective, how does it affect the organization? Do we have alternatives? Like if you're talking of alternative A, alternative 1, 2, 3, and probably at the end of it all you are able to make a decision, because when you're coming with a decision, in most cases we come up with different alternatives. We can either follow this route, we can follow this route, we can follow this other route, but at the end of the day there are consequences. Now, how do those consequences affect the organization? Because at the end of the day we are trying to make sure that this organization will survive. If this organization is able to survive and thrive well, then we are also, as employees within that particular organization, we are also able to do well. So it's important for us to be able to look at it from the perspective where you are able to understand that when it comes to the organization itself, technology and organization, they are all interrelated. Whatever decision you make based on technology, it will affect the organization. So the interdependencies between organizations and information, we are able to look at it from, we have the business strategy, we have rules and procedure. These are within the organization. Don't do this, do this, we can do this, we can go to this extent, and so on. That is the organization itself. Then we have the information system, basically the technology itself. Is it in terms of software? Is it the hardware? Is it the database? Is it the telecommunication links that we are using to connect maybe from one branch to another? That is all technology, and that's what is forming our information system. Now remember, I started by saying that we can run the organization without the information system, but at the end of the day, are we achieving what we intend to achieve at a much more faster pace as we would want to, efficiently and so on? If we are not, that's why now we are bringing in information system. Because think of it, think of a situation whereby you are running a supermarket. You are running a supermarket without the technology. I mean, customers come and then whatever it is they buy, you write it on a piece of paper for recording and all that. At the end of the day, how many customers are you going to be able to serve? So you can see, for you to solve that problem, then you need the information system to come into play. Now, moving on to different types of information system, because we have seen, if you look at the organization, we have different levels, and these are mostly the three levels. We talked about operational, management, and strategic. We have to look at it from such kind of dimension. Now, each one of these levels we have different information system. We don't have one information system running within an organization. Well, it might appear as though it is one system, but when we get to another level of organization, it becomes something totally different. The same system you would use as maybe a clerk within a particular organization, it's not the same kind of system your manager is using. It's not the same kind of system the CEO is using, though it might come packaged as one system. But the reason why we are saying it's not the same system, because it's based on what kind of data it's processing, what kind of output is given in form of reports, what kind of input we are getting into this system, and where is it coming from. Because I began by saying, like, if you look at the strategic level where we have senior managers, the information that is processed by such kind of system at that particular level would come from within the organization and also outside the organization. Now, if you look at, we have different color scheme here. We can say we have red, yellow, green, and I think is that bluish or purple. Now, all these indicate that if it is sales and marketing, there is a channel that goes from the bottom all the way to the manager, all the way to the CEO. So there is a decision process that is being applied from the top to the bottom. And that is why you saw that diagram we had earlier. There were arrows pointing to the operational, the management level, and the strategic. Because now if it is finance, from that point of contact, maybe you are from that first point of contact with the customers. You are a customer, you go to a supermarket and pay for a particular item. That is the first point of contact where we have the operational staff. This could be what? At the checkout counter, there is a clerk who's running your goods through the checkout counter and you make payment. That is the first contact. Then from there, it is that amount of money will be managed based on the head who is heading that particular department. That again will be managed based on what the CEO wants to do, based on, is the company making profits or not making profits. So for every department, there is a run from the operational level all the way to the strategic level. That's basically what you need to understand. Now, I mentioned the systems that we are having. Now, if you look at the operational level, there is a system that there is a diagram here on my right that I can see here. At the far end, you can see we have a transaction processing system. Now, if you look at transaction processing system, like I said, since this is operational, the nature of work or activities within this particular level is repetitive in nature. What it means by repetitive in nature, as I had explained, is that you are going to perform the same thing over and over all through the day. That's what you'll be doing. If it comes to the mid-level, where we have heads of department and all that, they are no longer now using a transaction processing system, but they are using either a management information system or a decision support system. Now, where is it getting information from? Now, this decision support system gets information from transaction processing system. That is the kind of information it processes. So whether you're using a MIS or you're calling it a decision support system, that is within the management level. And it's fed by information that is coming from operational level. That is how you know that this is MIS or DSS, whatever you choose to call it within that particular level. Now, when we go up higher at the strategic level, we find a system that we are referring to as executive support system. Now, this executive support system makes use of data that is coming from the MIS or decision support system. Now, the kind of system it is, or rather the executive support system, does not have a lot of features that somehow would have a steeper learning curve. It's a very simplified system that would allow any manager to be in a position to quickly access it, quickly interpret the data that is given out or information that is given out, because they mostly make use of graphics. Graphics are much more easier to interpret than textual information. Therefore, in those kind of system, you'll find graphs that are showing maybe like if you look at something to do with maybe sales, it can be a graph that can show this year these what we were able to these were the sales for this particular year, or these were the sales for this particular month, and so on. Simplified system, but it also makes use of information that is coming from outside the organization, as I had said. Now, if you want to understand more the characteristics of this transaction processing system, and remember, transaction processing system are at the bottom there of that particular figure that is showing the organization. So the tasks are of routine nature, as I had said, and therefore TPS are large and complex in terms of number of system interfaces and all that, because they are providing information to other levels. Control collection of specific data in specific format. That is the first point of contact, especially for customers and all that, or for organization. They are first getting data from that particular level. They are general in nature and apply across organizations. Like that example I've given you of a checkout counter at a supermarket. So those kind of system will be general in nature. Now we have a symbolic representation of a payroll transaction processing system. You can see how this system is simplified. We have a payroll master file. This could be some kind of database or a server of some sort where the information is being stored. Then we have online queries earning. That is, you can interact with this particular system and it is able to give give different reports to maybe the manager and so on. We can see we have management reports and all that. Then we have government documents, employee checks and all that. And then, because this system, besides producing information based on maybe how you are going to be paid and all that, and this information has been accumulated from various departments, maybe from the first day of the month all the way to when the salary is processed and so on. And that's why now you can see we have government documents, because we have information that is also going out based on how a particular employee has been paid and all that. So this is just a simplified version that can show you how information would move in a TPS system. And therefore, because we say they are simplified and they are similar in all organizations. If you look at all departments, you will find similar kind of systems, similar kind of movement of data and so on. So like here we are saying major functions of system, we would expect to have our customer service, sales management, promotion tracking, price changing, dealer communication. Those are the kind of things you would expect under sales. Under finance, general ledger, billing, cost and all that. If you look at these are basically just typical applications on where you'd find these particular kind of systems applied. Now, if you move on to the next level, that's when now you find the MIS. Now, the MIS would provide middle management with reports that summarize and categorize information derived from all organization databases, would serve management levels, and also provide reports and access to company data. So, and that's the reason why I was saying, like, if it is middle management, then information is coming from the transaction processing system. And that's why you can see input, summary, transactions, and high volume data that is coming from the operational level. And also processing routine reports and all that, and that is for managers to be able to make the right decision. Output summary and also exception reports and user middle management. Example, we have the annual budgeting. So we have characteristics of MIS such as professional. Professionals usually design MRS rather than the end users. Now, what it means is that would basically need to have developers who would come to work for the organization. That is, you can give them your requirements, specification for a particular system, and they are able to develop that, because now you need knowledge, you need to be skilled in programming for you to be able to do the development, but you can do the development without the knowledge of how this system is expected to work, and that is the work of the end users. They can be able to give you that information, and that basically happens. And when it comes to system development, we would have things like methodologies such as system development life cycles and all that, so they would assist in that. So they are large and complex in terms of number of system interfaces and all that, because they are feeding information from the operational level. Now, under the operational level, we can have maybe head of department managing several operations, and that would mean probably we are feeding data to that particular system from two different sections or sectors. So the MIS are built for situations in which information requirements are reasonably well known and are expected to remain relatively stable. Because the reason is why is because operational level, we are running tasks that are of routine nature, so they do not directly support the decision making process. They can do that, but they do provide information that would be helpful in that particular process, and therefore they do have limited analytical capabilities. For this particular system to be helpful a lot, it will need to have to have enough kind of features for probably processing and analyzing data and all that. And that now is pushed on to systems such as DSS or systems such as the ERP systems. Now, how management information systems obtain their data from the organization or TPS. Now you can see we have a diagram here or a figure here that shows us, like, if you look at the accounting and production, and then we have the order. All these can be stored in different databases. As you can see, the representation of those cylinders represent storage in computer systems. We can have order processing, we can have material RPS, that is resource planning systems, and then we can have general ledger system. So those are systems that are performing their daily routines, and they are storing that information there. Now when it comes to MIS, now this MIS is pulling data from all these different sectors. That is, it's pulling from the order, it's pulling from the production, it's also pulling out from the accounting. All that now it's able to all this information is able to be pushed into this one system, and out of this one system now we can be able to begin to generate reports that would give us maybe the health of this particular organization. And then now it's pushed to managers, either heads of sections or the CEOs of that particular organization, and then they can make a decision based on what a decision that would help move maybe a particular department ahead and so on. But remember, the MIS is within the middle level management, so we are referring to managers within the middle level management. We do also have the DSS, decision support system, which serves management level with data analysis for decision making. Now it has that capability to perform much more analysis as compared to the MIS. So you can even see the output is low volume data or massive databases, analytical models, just all that. It is able to run that. We have examples such as contract cost analysis. We can have a system that is able to analyze and give you information regarding that. So since in most cases we say that people under managerial levels, they do not have a lot of technical skills for them to be able to interact with computers like gurus. And in most cases, we find that those kind of systems that are used by the head of sections or the CEOs and all that, they are built to be user friendly and highly interactive. That is, they can they can even use touch screens to be able to access these particular systems. It's not a matter of typing codes there for them to be able to retrieve information. That's a simple system. They can make use of icons, makes use such kind of systems much more user friendly. It's all about making that this system can allow anyone with novice skills to be able to work with that kind of system. So remember I said that interchangeably sometimes it's the DSS or it is the MIS within middle level of management. If you look at the DSS, again, there is a figure that shows what we are talking about here. You can see the DSS are as an additional component that we do not see in MIS, and that is the analytical model database. It is able to analyze data. It is able to use mathematical algorithms to be able to produce the kind of data that you require based on queries that you have given it. And therefore, where is it picking this information? It's picking again this information from different storage that we do have. Like you can have the shipping files as given here, port distance, fuel consumption, ship charter, port, and all that. And it's able to analyze and tell you where you probably where you need to ship from for you to be able to make what to be able to pay less cost for you for such kind of transactions and make more profit and all that. Now, moving on now from the middle level management, we move on to the strategic level, and on the strategic level, that's where now we find the executive support system. These systems now are much more simplified, because we were saying people in management don't have a lot of skills when it comes to use of computer systems. So mostly they are more of novice when it comes to usage of computer system, and therefore we require systems that are even much more user friendly. And that's why you can see when it comes to processing, we're looking at graphics, simulations, interactive, and all that. Interactivity can come as a result of touch screens, all that. Now, under input, we have external and internal. It is at the top there. That's what I was saying. The data it's going to use for maybe generation of reports will come from within the organization, or it can come from outside the organization. It's not that or, it usually comes from within and outside the organization, because we need to know what is happening out there. They're making decision based on the survival of this organization against its competitors. So what are the competitors up to? Are there some regulations that have been introduced within by governments that would affect how our organization run, and how do they affect maybe our health as an organization? So we need to know all that, and that information is coming from outside there. They can also have, in terms of output, they can give reports or projections, because we're making plans for the next 5 years, we're making plans for the next 10 years, and so on. So it's not a matter, you don't look at it from the perspective where these managers are making decisions based on what are we going to do today, what are we going to do tomorrow. No, it's long term. In most cases, short-term decisions are made within the middle management. So we are at the top management, and we are looking at how we are able to achieve maybe a five-year goal that we have set, maybe a 1-year goal, maybe a 10-year goal, and that's where we have those projection. And the way we are operating with this system is we are giving it queries, and it is able to give us responses. So we expect them to be quite user friendly, and we have menu driven kind of user interface, and making it much more user friendly. So those are the kind of systems that you find within the top management. Now, if you look at the ISS, it's executive support system. There's a diagram here that basically now shows us where it's getting the data from, because I said we're talking of internal and external. If you look at internal, from the transaction processing system, from our MIS, or from our DSS. And I must also mention that sometimes we can have the DSS even within the part of the strategic level, but in most cases it's within the middle management. But you look at some texts, some textbooks will give you DSS within the strategic level, but generally we expect it to be within the middle management. So we have also finance data, office system, modeling. External data would come from maybe different data vendors, such as Dow Jones, Internet News, and then would have standards and poor. Basically, we are talking of any external information that can impact the organization. Then we need to find a way to channel that information into a system so that we can make use of that that data for us to be able to come up with a report, or rather information that is more current when we are making our own decisions. So all these systems, what we are basically saying is that all these systems are related. If you look at the TPS, the MIS, the executive support system, DSS, they all work together because we need them. Remember, I told you that it can be one system if you look at it, but at different levels of organization, based on what they're accessing from this system, then it becomes a different kind of system. So we have different functions within the organizations that would require support of such kind of systems, that we could have sales, manufacturing, finance, human resource, as many kind of systems that as many different functions or departments that you can think about. They all need the support of these information systems that we are talking about. And there is an example that is given here of sales and marketing IS. What would you expect there? Like, we can have order processing, we can end up process and track orders, and we can be able, it can work within the operational level. We can have a pricing analysis system. What would it do? It determine prices for products and services to ensure that we're actually making profit and not losses, to make sure that we are not overpricing our products or services. And that would be within the management level. We can also have a sales trend forecasting. In the next 5 years, what do we expect to be the cost of this particular product, vis-a-vis the materials that we are going to use to manufacture this particular product. The cost of materials going to go up, forcing us to have to raise prices. What will be the response of the market and all that? Where would we find such kind of system? Under strategic level. But when you look at it, all these can be just one system, but it has those different modules that are able to do that. It's one system. It has a order processing modules, it has a pricing analysis module, it has a sales trend forecasting module, but they are accessed at different levels within an organization. And you can see we have manufacturing and production system that can work in that using that kind of example. So as you can see, basically it's the same thing that we have just looked at. Under finance, still the same kind of operation. You look at the organization level and you are able to know under organizational level, this is basically what I'm able to do. Like, you can get a question in an examination system telling you to discuss different systems, how information systems within the organization and how they are applicable under different levels. Basically, these are the examples that you should be able to give under the human resource management. These are how it would operate. We would have the training and development. Under operational, we would have the compensations analysis and management. We would have the human resource planning under strategic, and this is how you would expect them to operate. And this is illustrated under the descriptions that we are having. Now again, if you look at the management information systems, organizations and IS, we have two-way relationship between the organizations and IT itself. Now we have two-way relationship between organizations and information technology. We were looking at organization vis-a-vis the information technology. And remember, at the beginning, we said that under organization, we have people, culture, politics, we have processes. And now, based on the mediating factors, we can begin to see decisions, we can begin to see processes, we can see chance and all that. So all these come as a result of an organization working, performing their tasks using information technology itself. So what basically is an organization? We need to be able to define it first of all, and we can only be able to define it from, again, the two perspectives, where we have the technological definition, and this focuses basically on where we are basically saying it's a stable, formal, social structure that takes resources from the environment and processes them to produce an output. So all the technology that we require for us to be able to process information until we are able to get the desired output, that's what we are referring to as an organization, because these technologies are working together. But this technology cannot be able to achieve what we are saying it's going to achieve as an output without us looking at the behavioral definition part of it, where we are saying it's a collection of rights, privileges, obligations, and responsibilities that directly are balanced over a period of time through conflict and resolution. And that is basically how you are able to build a culture within an organization. You agree on this, you disagree on this, and eventually you come to a particular resolution. And that has taken some time before you can be able to achieve that. So as a result of all that push and pull, it becomes part of your culture. Now, if you look at the behavior view of the organization, there is what is coming in and there is what is going out to the environment. Because I began by saying that a system, the information systems that we talk about are not closed systems. These are systems that are affected by the environment, and these are systems that also do affect the environment. And they have structure and process. What does that structure do? If you look at it, there is hierarchy, meaning that we have different levels within that particular organization. We have division of labor. Everyone has its own part to play, and those parts or tasks they play are a bit different, and there are rules that govern how we are going to be able to do that. And then we have business processes. Every time you hear of business process, think of routines that we have to perform every day. Whenever we say we are doing business or we are transacting business, there are some routines that we perform every now and then. If you look at it from the process itself, we are looking at rights and obligation of individuals, privileges, values, norms, the people themselves. And at the end of it all, if we look at structure and process, there is what we are going to give as an output. So we would have common features of organizations such as clear division of labor, that is structural characteristics, because when you're looking at structural characteristics, something that can be observed is something that we can basically be able to observe, or sometimes it can be abstract, but in most cases it's clear, such as clear division of labor. There is what you're supposed to do, and that is why you have this particular title as per the job description that you're given. There is hierarchy. There is operational. We talked of operational. We talk of middle level, and then we mentioned the strategic, which sometimes is referred to as the top level. We have explicit rules and procedures. There is what you cannot do within that organization, and there is what you can do. There is also impartial judgment. Can technology be in a position to help you to make decisions that are not biased? We have technical qualification for different positions, and then we also have a maximum organizational efficiency, because it is this efficiency that will bring value and lead to profits. So if we can be able to achieve all that, then we can say that we have what? We have standard operating procedures that are more efficient, because that's what I basically mentioned when it comes to business processes. These are basically routines that we can see. We have business process as a collection of routines. We have business farms as a collection of these business processes. Now, if you look at figure 3.4, it shows we have individual routines, we have business process. So all these different business processes would build into what would become a farm, based on different we have different departments or sectors within an organization, and each one of them would have to come up with its own kind of routine that would make you look at it and say, oh, this is the sales department, oh, this is the HR department, and so on. And beyond that, there is also the organizational politics. Politics will always be there, because we all don't look at things from one perspective. We have divergent viewpoints, and our divergent viewpoints, that's what make us what we are. But the most important thing is that if we are pushing towards one goal, then even though there is that diversity based on what we believe things should be, or how we should be able to achieve, which path we are supposed to follow for us to be able to achieve this particular goal, and so on. Those are the politics, and they will always be there in every organization. So it's up to us through conflict resolutions to learn how we are able to resolve all that. Culture within the organization will be built over time, as we have said, because it's through push and pull. Here, let's agree on this, we disagree on this. Eventually, through conflict resolution, we are able to settle on something, and that is what we do going forward. Eventually becomes the culture of that particular organization. So organizations are not similar, though they may have structures, goals, constituents, leadership styles, tasks, and so on, but they can be different in how they are doing those, how they are able to achieve all that. And that is what we are talking about when it comes to organization itself. How can systems help us, or influence such kind of system to a certain extent? Can we use information systems for us to be able to influence that? Now, looking at organizations, all have structure and shapes. We have Mitzberg. I don't know if you've come across this in business, but there is Harry Mitzberg, who was able to come up with more of a classification of organization structures based on frameworks to basically just help us understand how organizations are designed. And these would be based on what? Authority, control, and so on. So he was able to come up with simple kind of framework. There was machine bureaucracy, professional bureaucracy. So I would urge you to look at Mitzberg, because these are questions that usually does come every now and then. How technology can help influence different organizational structures and so on. So you can look at it from the perspective of Mitzberg's classification. Now, we do have what we refer to as environments and organizations having a reciprocal relationship, because an organization, again, it's a form of a system, because it's based on different components that are working together towards a common goal. and it is an open system, and therefore it will influence the environment, and it will also be influenced by the environment. Like, we can have government policies that would influence how that company is run. We can have competitors. Based on what the competitors are doing, what can we do much better? And therefore would find ourselves as an organization doing things differently to beat our competitors. What are our customers saying concerning maybe these products and so on? If we do our own research and R&D, what are customers saying? What do they want? And that can influence how we begin to give services, or what kind of products we begin to channel out to our customers. Financial institutions can also influence that, and also the culture that is outside there can also influence. We have knowledge and technology. As technology changes, we must also change how we are doing our own things, because if we don't change, then our competitors would use the best technology and they'll be able to beat us to that particular game, and that's what we do not want. Now, talking of how technology would influence the organization itself, it can bring about what we are referring to as IT flat kind of organization. Look at the diagram that we do have here. Now, the one in green shows it. These are normal hierarchy within an organization. You can see we sort of seem to have many different levels that can be there. Now, but should we bring technology into this kind of organization, then technology can take up some of the duties that are performed in different levels within an organization. As a result of that, eventually would have what a much more structure, or rather that somehow seems to be flattening. If you look at the blue triangle there, it shows that we have reduced the levels. They can even be reduced much further, because think of it. Think of an organization that sells what? Sells maybe clothes. Brick and mortar organization, where you have to go physically to a shop and look at the clothes they are selling, buy from them, pay, and then walk away. Now, compare that with an organization that has decided it's no longer going to have a physical shop, but they are going to have an online presence only. So they come up with an e-commerce kind of system where they post images of what they are selling, and you have to go online, make purchases, and then they deliver. So that kind of organization would have a much more flatter kind of structure, because this system will take up some of the decisions that are being made within that organization. Within a click of a button, you can be able to tell whether you're making profits or not. You can be able to tell where your traffic is coming from. You can be able to tell whether you are selling more kids' clothes or you are selling female clothes, and so on. So technology can assist in that perspective. So it's important for us to consider technology if we want to flatten organizations. And if you flatten organizations, then that means that you're keeping more profits than using it to pay maybe extra employees and so on. So internet is very important, and that's why I've mentioned that. And therefore, internet lowers the transaction and agency costs and all that. So under data resource management, if you're looking at data, eventually, data, these are basically raw facts. As I gave you that example of employee works 5 hours and is paid at a rate of 1,000 Kenya shillings per hour. Yeah, you can process that. Now it becomes a wage, and then that is information. So that's basically the whole thing that happens. You collect different bits of data here and there, bring them together, process them, then you're able to give reports that have much more informative content that can be used for purpose of decision making. We have desirable qualities of this particular information. Should be available whenever you need it, should be comprehensible, something that you can easily understand. So don't use complex terms when you're trying to explain simple things. Must be relevant, must be also secure, useful, and timeliness. Information should be available when it is needed. There are many desirable characteristics also based on the kind of organization that you are running. Should be relied upon, should be accurate, should be consistent, complete, economical in the what you mean by economical is that the process that you have been able to go through for you to be able to get that information, it should not cost you a lot. And that's why we're saying it should be economical and also should be flexible. So data processing, it's that process that you have to go to take that those raw facts, the process that you have to take the raw facts into so that we can be able to produce the end result, which is either our reports, and these are the reports are basically our information. So we have 4 stages of data processing, where we're looking at data input, and we're looking at the storage, then we're looking at processing, and then we are looking at data output. So sometimes you collect, you store, and then you process, and you perform data output. So these are basically stages that sometimes you come across data input, and then there is the processing, and then there is the storage, and then there is the output. It generally can be interchanged as such based on the kind of urgency that data is required. Sometimes there is not even the storage itself, it goes out immediately. So we have data processing activities such as recording, classifying, sorting, calculating, summarizing. So all this basically is what we have to take information through, like employee working 5 hours at the rate of 1,000 Kenya shillings per hour. So we run calculations, and out of that we are able to get, maybe this employee will get a wage of 5,000. So we have done calculations. So based on these kind of data processing activities, is not that we apply all of them at once. It might be applying just calculation, it might be just sorting out, it might be just classifying, you might be just comparing, all that. So you don't necessarily need to apply all those activities at once. We have different modes of data processing. We have online transaction processing. And here we are basically talking of where we have online means that data input device is directly linked to the transaction processing system, and the data are processed as it enters into the system. So if you have a way for you to be able to capture this information, and as you are capturing this information, you are processing it, comparing to a situation whereby probably you send data clerks out in the field, they go collect information, they note it down, then they later come and process that information. So that will not be online. Online is where it is directly connected, and as it trickles in, it is being processed instantly. Batch processing, what we do is we accumulate information over a period of time, then we accumulate data over a period of time, then we process it all at once. That is, we can have batches of different data that can be processed all at once, and these batches are basically what we refer to as a job. Real-time processing, these basically we are trying to process data without any element of delay, and we do have real-time systems. Like if you look at most sophisticated vehicles would have this kind of systems. Trains would also have this kind of system. Should there be a danger, it can sense instantly and then maybe apply a braking system of some sort instantly. Systems that are life-threatening would have this kind of processing going on. Life support systems would also have this kind of processing going on, so that should a particular activity happen, then it can respond almost instantaneously without any element or of delay at all. We do also have the multi-programming. Here we can have several programs being executed on a single computer at the same time. So And that's why we nowadays talk of multitasking and all that. You can be listening to music while the computer system is downloading something else. So all those activities seem to be happening at the same time. Hence, different programs are being run at the same time. So we combine multi-programming and multi-processing, but you should know how to be able to distinguish those two. Time sharing is a way of organizing, because basically what we say with computer systems is a computer cannot perform more than one task at a time. That's what actually we look at it from the actual sense of what is happening. If you look at the processor itself, what basically is happening is that the processor is split into what we refer to as time quantums, and these quantums are being shared with different programs. Like we could have three programs, program A, B, C. All of them require the use of processor. So what would be happening is that the processor will switch to one program, and then within a split of seconds switch to process what is on the other program. Then within a split of a second, and these are quantums, switch to the third program, and then back to the first program, and so on. So this will be happening so fast that it creates an impression like we have multi-processing. So multi-processing is not an actual thing, but in definition, it is there. So that is occurring because of that time sharing kind of arrangement. It's like you being told to pick three chairs, but you can only move one at a time. You move it to the next block, and you come to the next one, and so on. So if you are able to do that much more faster within the lightning speed, it would appear as though you've moved all those chairs at once. So that's basically how a computer operates. Now we have the database management system. Now, a database management system allows us to be able to create a database in the first place. Now, we store information in a computer system. In most cases, we have different types of databases, but the most common types of databases will be what referred to as relational databases. Now, relational databases, they make use of tables. So inside the database, we have tables that we use to store information. Now, for us to be able to create the database in the first place, we need a software that we refer to as database management system. It will help us to create, it will help us to add data, it will help us to edit or delete that data, it will help us to access this particular data. But in real sense, we don't directly work with database management system. We'll work with other applications such that when we request information, this information is relayed to the database management system, and it is able to retrieve this information and bring it back to the application we are using to access that information. I don't know if that makes sense, but look at it. Let's say you're accessing Facebook. You want to access your Facebook account. Now, we can have the application that we're referring to as Facebook. Then behind that application, we can have a database management system such as, maybe example, I give MySQL. And then behind that MySQL, or inside that MySQL, we can have your database. So the moment you are logging in, that application will make a request to your MySQL, which is database management system, and then it will request for that information from the database, the actual storage now, and then it can be pulled out and then populate that application that we are referring to as Facebook. So we have the application, we have the database management system, and then we have the database itself. So that's how we work with database management system. And a simple example of a database management system is the MS Access. I don't know if you have worked with it, but that one allowed you to actually directly work with your database. Now, we have different problems for traditional file systems. Now, what we mean by traditional file system is whereby you are storing information separately for separate maybe departments and so on. All this information is stored separately, not in one single location. And when you have that kind of storage, what happens is that, like, you find those guys in sales, they're storing their own information. Those who are doing manufacturing, they are storing their own information. Those who are in HR, they're storing their own information. Eventually, what would happen is that, like, maybe the guys in sales, they produce a particular item. These guys in marketing or sales, they want to market this particular item. What they call that item in their system may be different, completely different from the codes that you have it in under manufacturing. So we don't have a situation whereby we can bring this data together and analyze this data, analyze based on what we are producing and what we are selling. So it becomes a challenge. But if we add a system that would allow us to just have one single storage, where if we produce item X with code 100, then the guys at sales are also marketing a product that is called X with code 100. So that one would allow us to be able to merge information concerning this particular product and utilize it. But if we are not working that way, we are going to have redundancies, duplications, we are going to have isolations, we are going to have lack of flexibilities, lack of data sharing and availability, and integrity problems. Because this is what we manufactured, then sales, they have called it something totally different, and they're saying this is what has been sold. Then there's no way we can be able to link that information and come up with a good report, an accurate report. But if we are working from one single source, then we can come up with a complete and accurate report. So that is what led now to us working with a database that can allow us to be able to store data in a single pool. Hence now the advantages of database management system. Data independence for applications. That is, the database is separate from the application itself. Like in that example I've given you of Facebook application, and then in between there is a database management system, then there is your data. So that database is completely separate from the application. You can create another application that can still be able to access and work with that data. We have ease of support and flexibility, meeting changing data requirements and so on. You can make changes and they can be reflected everywhere. We have transaction processing, also efficiency, because we are accessing from a single source. And then we have reduction of data redundancy, because that single item we are storing as data item is the one that every other person in that organization is accessing. We don't have any other version of it anywhere. That is what we are accessing, hence there is no redundancy. So it also maximizes data consistency because of that aspect that I've explained. Opportunity also to enforce data or programming standards, and also we have enforced data security, because if it is in single location, we can ensure it is secured from that single point. But if we have data scattered all over different points, every department storing its own data, then we can have integrity issues and also security issues. We have data warehousing and data mining. Now, in most cases, we store information in a database, but over a period of time, when we do not require this information, or we are not accessing this information frequently, what we'd do is that we'd push it into another different source of storage, and that is what we are referring to as the data warehouse, historical data. We can be operating an organization right now in 2024, but would want some data that we processed maybe years ago, like 20 years ago. That data, since we don't access it more frequently, we can store it in a data warehouse. Maybe one of these days we might require it. Maybe one of these days we might need to go through that information to be able to see what kind of products we were producing, how we were marketing these products. There is some bit of information that can be very helpful for us in that particular kind of information. So we store it in in a data warehouse. It stores historical data. We have data marts, which are basically just subsets of that, more summarized. We have data mining. Now, if we want to access data from that data warehouse, since it's historical data and can be huge, it can be a lot of information that we have stored there. And we are basically just using that data for purpose of looking for patterns. How did we market? How were the sales during that particular time? Vis-a-vis maybe the earnings of different groupings of people and so on. Now, that is, we apply data mining onto data warehouse, where we basically now begin to use some mathematical algorithms for us to be able to get those patterns, and then probably apply the same pattern for us to be able to figure out what probably the future could be based on what we are producing. So a data warehouse would expect it to have internal data source. It can also have external data source. Besides that information we have stored in the data warehouse, maybe for like 20 years ago, we might also have another additional pool of data that we have pulled from other related resources, hence the external data source. So we need to be able to clean that data, make sure it is in the right format, especially the one that we are getting from outside the organization, so that we can ensure compatibility and to ensure that it's data that can be of value. Hence now the data warehouse, and we can be able to access it through different queries, online application processing, data mining, and all that. So we have benefits of data warehouse. There is improved information accessibility, and there is also ability to model and remodel data. That is, you can look at it from different perspectives. Like if you are a company that has been selling vehicles over a period of time, you can look at it based on maybe a particular year. What kind of models were much more sellable? What kind of maybe what kind of what models sometimes we look at vehicles based on the year of manufacture and so on, so that can also help you be able to figure it from that particular perspective, because now you might look at it from the perspective of maybe months. Which months were you selling more? Probably you might realize maybe towards the end of the year is when you're making more sales of cars and so on. So you can look at those trends. Are they still, is the trend still the same, so that you can maybe put more effort in marketing during the ends of the year and so on. So there is a lot of beneficial information that you can be able to get from that. So IS development, when it comes to these information systems that we've been talking about there now, how do we develop these systems? How do we get to say that now we have an information system that is helpful for us? So there are activities that we must go through. Number one, we basically need to look at it from the perspective where we identify that there is a problem. How? Now, look at this. Let's say you are running a shop, a small shop, and how you deal with your transactions is that just pen and paper. You write down, this customer bought bread, you write down. Another one bought milk, you write it down. But as you grow and you decide, now I'm going to become a supermarket, that is a problem. Now you have a problem there, because you cannot do pen and paper kind of record system. Now you need an information system. So there is a problem. That is a problem that needs to be solved with an information system. Now you can either go and buy a system straight up from those technology shops that we do have around, or what you can do is that you can call a system developer to come and look at your problem, analyze your problem, and so on. That will be a system analyst who can come and talk to you concerning what kind of system can be much more applicable for your organization, what kind of features this system should be having. Now you'll be telling the system analyst what you really want and so on. And at the end of it all, you will have collected your system specifications. which you'll need to record in a specification document. Then he can go and write it again in his own language based on what he has understood, based on what you were saying or what your employees were saying, and so on. Then he can come back again and take you through the whole process again of what you said, what he recorded, and so on. Then once you agree to that, then he can go back and start the process of working with his team to develop such kind of system. Of course, after you have agreed on these are the specification and you sign, so that next time after he has developed this system and he comes with the system, what happens is that we can go through these specifications to see if he's been able to achieve all of them. So the whole of that process is basically what referred to as a development life cycle. Now, we have a very simple methodology that we do refer to as system development life cycle, where we begin with system analysis, then we move to system design, then programming, testing, conversion, and production and maintenance. What we mean by system analysis, that process that I've basically explained. Whether when you're saying there's a problem, is there really a problem? Do you really require a new system? Because sometimes you might have a system that is working and you come to the realization that this system actually is not a problem. It's not that it's a difficult system. It's only that you have not been trained on how to use the system. Then there is no need for a new system. You need training for your organization. But should there be a need for a new system, then you go through that process of collecting what your requirements and so on. Then you can have design. We can come with drawings that depict what the system will look like, prototypes and all that, agree on that. Then we can have programmers start coding using programming languages to code the interface, the backend and all that. And then eventually we have a system. We can run a test to see whether this system is operating as we do. Once we agree that this system is actually operating as we perform our operations within that particular organization. Remember, we talked of cultures and all that. Does it obey all that? And is it able to deliver? Because sometimes you can have a very elegant system that looks nice, but is not doing what you want it to do. So that one would not have delivered. But should you be satisfied that this is actually the system you want, then we can perform conversion. What do you mean by conversion? Is that you've been having another different system, and now we need to change to a new system, carrying our data from the old system to the new one, having employees learn how to use the new system. Then eventually, should there be any changes that are required, that's when now we move into what referred to as maintenance. We call the programmers again to come make slight adjustments here and there and so on. So that is maintenance. So that's what system development life cycle is. You can read it here. Like under analysis, what I forget to mention is that there is something that we also refer to as feasibility study. In those initial stages, you say that there is a problem. Okay, we tell you this is what you need. The system analysts say this is what you need, this is the kind of system you need, and so on. Then we agree to that. But the question is, there is a feasibility study. Feasibility is just another name for possibility. And what we are asking under feasibility study is, this system you are saying that you require. Now, do you have the finances to support it? How much will it cost? Do you have enough people who have the right technical skills to develop that kind of system? Will this system be economical to you, and so on? So that is a feasibility study we are basically doing there. We can also have a steering committee. It should include senior management, technical staff, and so on. So this is the committee that will be approving some of these things. Because when it comes to development of systems, if you don't involve the top management, then it can never work. Because these are the same people who are going to approve payments and so on. So it must work. Again, if you don't involve all the employees, then when you bring this system to the organization, they will not feel that they own this system, and they might begin to rebel against this system. Now, the feasibility studies that I was talking about are technical, economical, legal, operational, and schedulability feasibility. So when you say technical, do you have enough technical resources or experts? When you say economic feasibility, we look at the costs of it all based on what you're going to profit. Legal feasibility, are you developing a system that is legally acceptable or something like that? Because you can be calling a program to develop a system for you for hacking. Is that acceptable? Operational feasibility, will it be able to solve your problem and all that? Schedule feasibility, if I tell you I'm going to deliver after 2 years, is that really acceptable? Or you just want a system that you can start with within the next 2 months and so on? So those are the things that we are talking about when we are talking of feasibility. Get details of present system performance, get details of establishing the computer literacy and relevant skills, also to ensure that new system developed is acceptable to users and also can give the proper reports. So if we go through these, you'll be able to understand that there is what it takes for you to say that you have a system. And that is why you'll notice that some organizations will not want to go through that kind of process, because you are developing a system that is uniquely yours, and that can be costly. So what most organizations will do is that they will go for what? For off-the-shelf kind of system. These are systems that you go to software vendors and just buy, and the next day it's operating within your organization. It doesn't have to take that long and so on, but you understand that such kind of system is not built exactly for your organization. It's general. So some features may be there, you don't necessarily need them, and so on. And that's how you have to work with it. Others, what they basically do, they go for open source kind of system. Open source kind of system, you don't buy them. These are freely available softwares, but you can have developers just make slight adjustment, customize it so that it can fit what you really want within that particular system to for support of your operations. So organizational analysis, we are looking at study of organization, including the management structure, people, business activities, environment, all that. When you're talking of that analysis, basically we're establishing information requirements, stating information needs that new system must satisfy. And that is why in most cases, if you are talking of bringing a new system into the organization, you must consider your business processes, because we say that business process is equals to routines, and all these business process or routine would lead to what the firm actually really is. And therefore, we need to determine what type of information each business activity is required, and also try to determine the information processing capability. And also, we need to have a goal to identify what should be done and how it should be done. We do have examples of functional requirements. You look at the system, you look at it based on, look at the interface of this particular system. Are you able to interact with it? Are you able to, is it easier to use? You look again at the process. If you enter data, how is that data processed and so on? Is it in line with what you actually do within your organization? Then how is this data stored? Is it easier to retrieve? Is it easier for us to make backups? Is it easier for us to be able to protect it when it is stored, wherever it is stored? Controls that you might need to ensure that you have there. Who can access what, who cannot access what, ensure all those things are there. Then we can do the system design itself. Now, how will the system meet information requirements as determined by the system analysts? Because you need to sit down. Yes, we have given the requirements. These are the requirements we expect from this particular kind of system. Then what do we need? We basically now need to come up with designs. These can be even done in form of prototype. A prototype is basically a model of the actual system. You can create a prototype through either drawings or dummy systems that are not really functional, and then you come and demonstrate to your client on how you expect this system to operate and so on. We can have programming. Under programming, we're basically looking at writing now these, developing this system using particular programming languages and all that. Once we have done that, we must always be able to test this particular system. That's why you have unit testing, system testings, and then acceptance. Nowadays, when you are developing system, you like to approach the problem by dividing it into different modules. Once you divide it into different modules, now you can have different modules being developed by different teams. So these different teams, whatever they develop, they must test, hence it is a unit they are testing. Now there's also what referred to as integration testing, when we bring these different units together so that they can work as one different component, as one single component, that is, then we can perform the system testing or integration testing to ensure that there are no errors. Then eventually now we can take this software to a particular organization that gave us that job or our client, so that the client can test whether it is working according to the system requirements we gathered at the beginning. If it is working, then that is the user acceptance testing that we are talking about. Remember, we talked about conversion, and I said conversion, we are basically now doing what? Moving from the old system to the new one, but you just don't jump. So we have different strategies that you can use. You can decide, let me do a parallel strategy where you are running the old system and the new system together. And for purpose of comparing, so that you can also get the confidence whether it is actually doing what you really expect it to do. Or we can have a direct changeover where we immediately cease using the old system, we are now using the new one. Or we can have a pilot strategy or a phased out strategy. What we basically do is that we can decide to implement this in a different branch. We say, since we have 3 branches, let this branch run the new system so that we can see how it operates, or let this department first begin using that system and see how it fares, and on and so on. Once we are sure and we have the confidence that the system is working, then we can do what? We can be able to roll it out to the entire organization. So each have its own advantages, disadvantages. Like, of course, when you are running parallel, basically it means you are running 2 different systems, and therefore you need more employees to either manage, you need more resources and so on. So it has that disadvantage, but it's a way that you can be able to have a system in your organization, and people can be trained as they do what? As they observe how it is working. Direct changeover, basically, you are changing straight to the new system, so we don't have additional cost there. Disadvantage can be risky because you can change straight and then that system fails. So you might end up losing customers if you run a very crucial operation. Pilot changeover, we say that you're only applying it in specific department. Phased process, implement only parts of it, like we can start with a single module and so on. So the difference between the pilot is that a pilot can be a full system, but let's do it at a particular department. A phased conversion can be, it is a system but just a part of that system. So we can have a module run there. Let's have guys at HR begin using this system. If it is working well, let's add the component for sales and so on. Eventually we have everybody using that particular kind of system. And as I said, eventually once we have the system running, should there be any changes that we want to perform, then that is what we are referring to as maintenance. Prototyping basically comes when we are doing what? When we are doing the system analysis. You create a prototype of the same system so that you can come maybe and demonstrate to your client, so that the client can be able to figure out whether you really were able to understand what they really wanted based on this particular system. And there you can identify the user's basic requirements, develop initial prototype, use prototype, revise prototype, and so on. think of it, maybe you are modeling a house and then you come with what do we call them, a prototype, or there's a name we use for those small models of houses that we do develop. Then maybe you can come, sometimes they make them using boxes. You can come and demonstrate and say, oh no, we don't need a wall here, we need a wall this other side. It is easier for you to make changes rather than you start the whole thing and then we say, no, you must demolish this and do this and that. It becomes costly. So we work with prototypes. They make things much more easier. They save time and they also save on cost. So you can read a lot more concerning that in this particular section. Disadvantages is that they can only be successful if system users are willing to devote significant time, because I can come with a prototype, but you have the time to for me to take you through that prototype so that you can look at it and agree whether this is basically what we say. Interactive process of prototype causes prototype to be experimented with quite intensivity. Sometimes if it is a functional prototype, like it can be a software that can allow me to move from one interface to another. That's basically what we mean by that. A prototype may cause behavioral problems with system users. That is, these problems include dissatisfaction by user if the system developers are unable to meet all the demands. But that should not be a disadvantage, because that is what we want. We want the client to test until they are satisfied, because the moment we start coding, that is it. We don't want to be moving back and changing this and that. That can introduce additional costs. We do have end user computing, and this basically refers to a situation in which end users of an organization and decision support systems are involved in the design process. You need to involve the end users, and that is the only way they will own this particular system. The moment you bring the new system to the organization, they will feel part of it and they would have known how it will influence their jobs. But if you just all of a sudden introduce a new system, then they begin to revolt against that. They fail to accept this particular system and it becomes a challenge. That means you need to devote more costs to training and all that. So that marks the end of this particular class. See you next time for the next class.